Hello, everyone. I think we'll get started now. It's one thing about having a webinar just before the Christmas holidays. It's something not well attended, but that's okay. We've got 11 of us here and 11 attendees. That's fine. It'll be well worth your while. It's exciting, cool stuff. And we might repeat it again or have it recorded and show some people later. So if you don't mind, we'll give it a couple more minutes. I'd say it is now 12. It is now 12:03. Okay, one more minute and we'll get started. Okay, so let's get started. Okay, this is Ted Knack at this end. Welcome, everyone. Today we're going to go over our next, basically this month's installment of our Extracting Value series. And this one is not about TopoDOT, though. It's a special edition topic. It's our TopoPLANNER and TopoMISSION web apps. And it's exciting. We have hundreds of users for these applications. And the fact that we've put them on a web app is very exciting, because one of the main restrictions to a lot of people using these is that they fundamentally couldn't get them, and they couldn't download the downloadable version and install it. So now that's not a problem anymore. And what you're going to see is that TopoPLANNER and TopoMISSION are going to help you with your LiDAR projects quite a bit in accurately estimating them, and accurately estimating your cost, your schedule, and your basically overall layout and planning. So let's get started now. Lindsay, are we recording? Okay. All right. So real quickly, for those of you who don't know what TopoPLANNER and TopoMISSION is, we'll talk about that quickly. But let's just introduce ourselves for anybody here for the first time. My name is Ted Knack, and I'm president of Certainty 3D, and it's Lindsay Messer, and she's our sales manager. And basically, we're here to, we don't have the tech guys here, so TopoPLANNER and TopoMISSION are so easy to use, we can do it. So we don't have Mauricio is on holiday, and all the big guns have gone to lunch. It's just us. The big picture, so why TopoPLANNER and TopoMISSION? And the webinar series, I always like to say why we're doing this. Basically, everybody knows this. Accurate project estimation is key to technical and financial success. If you don't accurately estimate how long it's going to take how long it's going to take you to do your project, how much it's going to cost you. In addition, not only scanning but placing control. You don't want to find that out at the end of the project that it took twice as long and cost twice as much money. That's kind of recipe for disaster. So the other thing is that education about the process develops a sense of confidence. The thing about TopoDOT and TopoMISSION, it gives you a means of very, very clearly explaining to your customers, or your customers asking you questions, coming back to the data provider, what are you doing, where are your routes, why are you putting control here, do you think we need more control there? It develops a communication and a sense of confidence in the entire process. And it educates, too, because you start to understand what's going to be done and why. And of course, effective communication closes the sale. If people understand, if you're a data provider, and whether it's within your own company or to an outside company, you do this as a service provider, when you can explain exactly what that project is going to look like and how you're going to lay out your scans or your route for your mobile scans, and where the control will be and why it's going to cost what it does, then they have basically an appreciation for what you're doing, and that's how you close a sale. So we're thinking that these are very, very excellent tools. So right now we're going to get down to the demonstration. Okay. So bear with me while I basically open up our website. To get to TopoPLANNER and TopoMISSION the first time, all you have to do is go to Products and Free Planning Software. Take you to the page for TopoPLANNER and TopoMISSION. Now, TopoPLANNER is an application that's focused on static scanning outdoors. Okay? So if I click on here and I put my name, I basically enter my name, my email address, and I provide a password, I'll get in. After you've been in once, you can copy this URL and just basically go there directly right away. Okay? So now you're working with a Bing, in the Bing environment, so you get these Bing, these overall backgrounds, these Bing maps. And let's go to our hometown here, Orlando, Florida. We'll go to our zip code and move right into our neighborhood. Okay. I'm going to start by looking at the aerial, and again, I'm in TopoPLANNER now. So let's look at the aerial in TopoPLANNER and focus on a small job, and we're going to lay out a project right here. So TopoPLANNER, so right away we get to, we're going to say, look, there's a particular project, and the project is basically from this intersection to this intersection. It's a DOT or a municipality, whatever, somebody, they need that scanned, or they need it surveyed, and you're deciding, do I want to do this with a scanner, or maybe you're deciding what scanner should I use. So that's the key here. So there's the project, this intersection, this intersection. The first thing we do is look at the system configurations. Again, for our European friends and Canadian friends, you can do all these in meters. We'll keep it in feet. Most of our attendees are in the U.S. today. Control parameters. This basically asks a simple question. How many minutes, and we should probably put minutes in here. So how many minutes does it take you to place a control point? Now, a lot of this control are done with RTK for northing and easting, and then they run levels, do a level run afterwards. So basically, from our experience, and we're not surveyors, but our customers tell us you can put it about 6 control points in an hour. So 10 minutes, all right? And I'll make sure minutes get put in here. And then what's the distance between them? Well, this 175 feet, again, these are in feet. I'd actually, this is just a nominal distance, and you have to go by the actual site, but I'm going to put 250 here. And what does it cost you per hour? Well, I don't know how, $175 an hour to put out this control. The next thing you want to do is parameters. Now, we have in the system parameter list, we have basically entered some of our customers have provided us background parameters to put in for these systems. And these are systems we have experience with, and these can all be modified. And in fact, we're going to put another category here that'll have custom systems. So you can basically just customize your own system, call it what you want. Right now, let's start with a Regal VZ400 with a tripod. Okay? Again, change your numbers, and I'm going to change a few here. I'm going to fine-tune it a little bit right here. When I look at the Regal VZ400 with a tripod, the first thing I see is a green scan time, yellow scan time, red scan time. Okay. This is time per position, again, in minutes. This is not the length of the scan. The scanner will scan around depending on what your resolution is, but typically in a minute or less. This is everything. Setup time, find your targets. Basically, the way to determine this time is to ask yourself, if I work 8 hours, how many scans do I get? Divide that and get me the minutes per scan. So this is the operational time. Now you'll see there's a green, a yellow, and a red. Again, for this particular Regal and this is quite conservative, but after an 8-hour day of carrying the scanner from one place to another, setting it up and things, this is probably a reasonable time. You'll get about 4 an hour, maybe a little less. But the yellow we add a few minutes and we add a few minutes here, and these times are basically if you have more congested areas. We noticed if we're around the stoplight, for example, if we're around a traffic signal, you'll spend more time because the traffic will just stop and you have to scan again perhaps, and you got to run the scanner again, or there's cars in your way between you and a target. Okay, so these are the things that may take longer. So when we're around a traffic or an intersection, we'll use these red. We'll use this time, and you'll see how that works. The next important aspect of where to set up your scans is your coverage. Now, if you notice, the parameter we put in is scanner height, not scanner coverage. If I change this to 11 feet, I get 161 feet radius. If I change this to 5, which is about a tripod height, I get 73 feet. Again, you can change the meters and you'll have the same thing happen. Why do we do it by scanner height? I will explain that shortly. But doesn't have very little to do with the range of the scanner. Now, the next parameter is a control target range. This is how far you will effectively see a control target, and that the control target is your reflector, and every manufacturer has their own kinds of reflectors. Basically, how far will you see? Now, I would encourage you not to put the max range, because in these kind of environments, for example, in the Regal, on airports, I've found targets 800 feet away. Do not put 800 feet in here. You'll never get a clear line of sight, or it's impractical. I'm actually going to put about 275. I'm going to up this a little bit. And this is typically what I can expect to see the targets. And this is important to put a reasonable number here, and this will be the targets that are within the range of your scanner. Operational cost. Have your accountants, you figure it out how much are you spending an hour to be in the field with your scanner. How long is it take? It's paying for the scanner, paying for your cost, your overhead, your personnel, everything. But let's put a number in here of $250 because we have a scanner and we've got to pay for it, so it's more than just doing control. Okay, so once those parameters are in there, you enter that, and I'd like to take you now to talk about a little bit about that coverage issue. And so if you don't mind, I'm going to pull in another slideshow. And if everybody can see that slide, basically the way we determine range, this 73 feet, is just based on when we have about a 5-degree angle from the beam from the scanner to the road surface, to a horizontal surface. This is subjective, and I don't, maybe 4 degrees works, maybe 3 degrees. We find that at 5 degrees you're getting pretty parallel to the road surface. That's really the effective range when you're doing these projects. The Regal scanner, for example, we know is 1,500-foot range. I'll see buildings a long way away. But the road, data starts getting a little flat, and this is when you'd start your scan again. So that's why it depends on the height. Of course, if I move it higher, the range increases. My 5 degrees comes out here and the range increases. So, and every scanner operator that's tried to put their scanner on a 12-foot tripod understands this, in addition to looking over targets, and that's why we invented TopoLift, but that's another story. But that's where that coverage comes from. Basically, that's the radius of the coverage from the scanner. It has to do with this angle to the street surface. All right, so that's the circles you're going to see. All right, so let's take a look. We're going from this intersection to this intersection, and the first thing we want to do is set control. So I'm going to click on Create Control Point, and you see this. Remember, I put 250 feet here. That's the radius of this circle, and what that does is serves me as a reference. So I'm going to zoom in, and I'm going to say, look, the first guy I want to put control. I'm going to start at this intersection. So I'd like a control point here, here, here. When I do intersections, I like to put the control a little closer. So I'm going to put them on hard surfaces. Hard surfaces are best. You can compare them better later. But once they're down around here, I can actually move to my 250 feet, which is my radius. So now here I put the next one. Here I'll put one here. You see that radius, that circle, that gives me that 250 feet. So I know they're pretty much approximate distance apart. Obviously, these are approximate distances. I have to put it where it's possible. So do I want to go under the bridge? Perhaps. I might go a little further, but I'll put one here, I guess. And this, I might put one in the beginning. Again, for a bridge, I may actually increase the control if I really want to. If I really have to do some measurements. I want to feel better about that control there, so I'll put a few more points out. But once I get here, I can put these 250 feet apart. Again, not quite, but here's a good place to put it. So, you basically use the scenario, the scene, and you do common sense things. So again, this is 250 feet. Again, we'll go and put it on each. This is we're ending up here, so we'll put it on the hard surfaces. And you can, there's actually a Android app where you can download these and give it to your crew and say, this is about where we want to control. So they can actually find out what, basically say, okay, we want control about here. Again, 250 feet falls in the middle of the road. We'll put one here. And maybe since we have an intersection, we'll put another one right there. All right. So there's the control that we'd lay out for that project. If you look down here, that control will take you towards 21 points, and based on the parameters, the operational parameters you you inserted, it's going to cost you about $612 at 175 bucks an hour, and you're going to work about 3.5 hours. Okay. Now the next step is to basically put in your scan positions. Now, remember, there's a light, there's a lot of traffic here. We're going to use the longest scan position at this intersection, which was the 24 minutes. Now, you see the vectors. The nice part about this tool is that everywhere you are, everything within 275 feet lights up. So you get a feel for which control targets are going to be close to you and will be in a reasonable range. Now, you have to be careful. If I'm on a tripod, I generally won't see the ones across the street because there's always going to be a car between myself and the control. If you just see these two, you may have to just say, okay, I'll use my inclinometer, or I'll level. If I have a C10, if I'm operating like a C10 or so, I'll run my levels and I'll use this two control points. However, or set up over 1 point, back sight, whatever you want to do. But it gives you an idea of where to set up and how to affect this scan. So now, scan position here. When I'm in intersections, I like to look at each corner. And remember what we talked about, the radius here, that's the 73 feet. And those of you who have scanned in these environments, you start to realize what I'm saying. Your scanner can have a larger range, but the data here starts to get sparse on, when you start getting 75, 100 feet, for our European friends, 30, I'm sorry, 7,500 feet, 30 meters, somewhere around that. You start to have to overlap these. So when these overlap, you're getting pretty good coverage. Now, since I have a lot going on here, I'll overlap them pretty significantly. And this is where my setups will be. So there you have a light, and I'll take some more time. Here, not so much, so I'll go to the green here. This won't take as long. And we'll place these down here. Now notice I'm having the circles touch. That gives me pretty good coverage. Now, again, I'm probably not going to see those targets across the street, or I'm going to have to really work at it if there's no traffic. But I will see these down the line. Be careful. Do not resect just moving targets down a straight line. That will be a problem. So use your level, whatever. If you level or if you use the inclinometer, use those effectively, and that's the way you'll do it. If you can get up high enough to see over the traffic, or you have these on 8-foot rods and you're high enough, you have a topo lift system, that's another question, you can basically see them across the street and you can use them. All right, so let's set these up here. Now, quickly, I just go down and I set these up. And you see how I'm just overlapping. If there's a little space missing, this probably won't be a problem. These aren't that strict. A little over space, but again, there's not much happening here, so you don't have to cover everything. Basically, will I be able to set up here quickly? Yeah, sure. I can come in here and set up, of course, in front of the bridge. Again, this keeps me from planning. See how if I go too far, I'll start missing data in here. I'm getting a little far away. So make sure, it looks like I'll need another scan here. Do we do one under the bridge? Yeah, probably. So that's under the bridge. And let's just keep moving. So we're just going to accelerate the process here. Again, here I'm going to do another one under the bridge. There's always more detail. I want to get under the bridge, and then I'll go from up top. And again, you see the overlap with the edges. I should have no problem with these curb lines. Again, here, I probably, if I'm really going to be accurate, I may, because these curb lines, you want to get at least one scan here that these cars are going to be parked. You may not get all the curb line you want. So we're going to put a yellow one. This just says, I'm going to take a little longer because I may have to wait until these cars are gone before I scan again. But let's go back to the green now. And well, let's go to the red here because I have definitely a light and a light. And these are just turn-offs. That shouldn't be much of a problem. And I can probably get away with this. And here. Now, interestingly, this is getting a little sparse. I may, if I want to be very conservative, I may say I may have to go here in the center. And now I just keep going down the line. It has to be a little farther away from me. And once again, this is how I'm going to set up. I see a little bit of distance. I'm probably going to put one here just to fill this in because there's two bull noses here, and these are things I want to get. So I'm going to put one in here. And all I have to do is go to get to the other side. Is this here, 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 and again, I'm coming to a intersection, a very busy one, so, and I'd like to get 4 corners on that, regardless of the distance. There's a lot going on there. Okay, we've laid out a project. This project is, approximately, how long is this project? Let's take a look. We were supposed to put a ruler in here. We're going to promise to get to that. But with each of these being 70 feet and one, so that's about 150. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 14, 15. So 15 times 15 times 150 feet is at 2,200 feet. So you have about a quarter mile. And a quarter mile, it's taken me about 36 scans, 11 hours to do, so a day and a half. I got a half a day into control, so I would be finished in the field here in probably 2 days. Based on my cost or what I want to charge or however you want to use those numbers, I would spend $2,800 based on my scan times, and I would pay about almost $600 for my control. And that's how easy it is. We've used this extensively back when we were all back in the Rigo organization. We developed this, and if you put the right parameters in and you take your time, you should be within a couple hours of how long it takes you to do a project. So the nice feature here is that you can save this project now, and you can put it anywhere you'd like. Call it whatever, Sand Lake project. It's a CML file. You save it, and you can pass that amongst yourselves. Give it to provide it to a customer. Is this the scan positions? You can basically communicate within your organization and outside your organization about what you want to do. You can also verify which scanner might work for you. If a scanner is taking 45 minutes to position, do you want to use it for that? If it's faster, obviously you'll save money down in this corner. These are the issues that you can use this TopoPLANNER for, is actually to specify equipment. So actually, typically I wait till the end, but there's some other tools here. They're very self-explanatory. If I want to delete a position, I can delete it. If I want to add it again, obviously it goes back in. If I want to move a position, it's no problem to move it. Okay, so, and that's it. I think we're going to unmute everybody, and if anybody has any questions on this before I go to TopoMISSION, maybe we can have a nice conversation. There's 14 of us, so we could actually have a couple of calls. If anybody has any questions, please let us know. Any questions out there before I go to TopoMISSION? Nope, all clear. Question from Stacy. Hello, Stacy. Stacy, can you hear us? Okay. Stacy, you're unmuted. Can you talk to us? Or can you type your question?
She said she didn't have a question.
Oh, okay. I see a question mark next to your. How about Nick? Hello, Nick. How are you doing?
Not bad, not bad. I've been out the loop for a few weeks. Is there still an offline option if we haven't got access to internet, if we're at site or?
Yes, there is. And there's still a downloadable option, and that's not a problem. I think you will have to maintain them both.
Yep.
Right now, they're pretty similar. Again, one of the problems with being offline is that a lot of state agencies couldn't download software at all. So
Right.
that's why we came with the web app. You just, everybody thought it was a great idea until we realized nobody can use it. That worked for a large agency or even a large company that wouldn't let you just install software.
Right.
We in small companies get a little spoiled that way.
Yeah.
So yes, so right now it's available and you're still on the website.
Cool.
Okay.
Yep.
Anybody? What do you think, Nick? Do you understand what we're doing here? I mean, I think you.
Yeah, I've used it on several jobs on our M25 motorway for quoting to our highways agency.
Really? And how well did it work? Did you get close?
As long as as you said, as long as you don't over-egg the parameters, if you're realistic with those,
yeah,
it comes in pretty close.
Exactly. You can't lie to yourself because
no.
If you lie to yourself, yeah, you do get great numbers and you make no money. So it has to be based on empirical data.
Yeah.
Okay. Well, great, Nick. Good talking to you.
No worries.
All right. Anybody else out there? If there's no other questions, we're going to move on to TopoMISSION. Excuse me. All right. So once again, let's close. We'll close TopoPLANNER or open up a new. We'll go back to. We'll go back to here and go to TopoMISSION now. TopoMISSION has the same idea. You'll go into our TopoDOT website, or certainly 3D website, and you'll basically log in. And came the same kind of input. And again, TopoMISSION is for mobile projects. So let's go to the same place. And we'll just put in our zip code and go. And now, of course, we're going to do more than just a small little area. Excuse me. We're going to do a highway. I like the aerials to start, and this is I-4, for those of you not familiar with Orlando. So we're going to do a section of I-4, and we're going to plan out a mobile job. So let's look at the aerial. And let's start the process. So once again, you have the same kind of setup, but in this case, we have a cost per mile. That's typically, you can either decide what your costs are to estimate what your costs are going to be or what you want to charge. So let's say it's $3,500 per mile. and that's what you're going to charge, or your cost, however you're from whichever end you're estimating this. And your control point time, here we have 10 minutes again, and I would suggest that you actually put in 25, because these control points are going to be 1,000 feet apart, typically, okay, with the exception of between bridges and things, but they're going to be much further apart. So just carrying your equipment and getting between 1,000 feet is going to take you more time. But we'll escape the same price at $175 an hour, and you save it. The control, in this particular, in creating a control, in this case I'm going to do this second. I'm going to lay out the trajectories first, and I'll put the control in second. And we actually have two categories for control points. There's a blue and a brown. And the reason we do that is because many times there's existing control. You can import control points, and you can apply them to one of these two categories. And a lot of times you have existing control, and you want to actually take control off that existing and then plan out your, and then basically add control. Or you may want to take a control from a project, and you may want a third party to put out blind spots that you want to check the mobile data with. Again, so if these are different colors, it gives you the option of differentiating between two sets of control. Okay? And then, of course, we can export those control points. Again, I said we can import those control points, and very, very straightforward, really. Okay, so the neat thing, and this used to take hours, by the way, I mean days, actually, to plan out a project, and our customers said this is going from days to hours. So let's take a look at what you can do. We're going to start on the south side of I-4 here. It runs north and east through Orlando. And I'm going to start a new trajectory. For those of you not so familiar with mobile data and mobile projects or mobile technology, is that every trajectory, every pass is a trajectory, and there will be multiple trajectories here. So let's call this, we'll give it something a little more explicit, I-4 north, and we'll give it a number 2 and an index of 1, and we'll say okay. There are attributes that can be changed, and I've got to remember how to do that. I did that before, but these attributes can all be changed. How fast you're going to try, we're going to leave the standard things here, the drive cost. Okay, so let's do that again, and I'm going to remove this, and I forgot to say that the attributes. So, system options, control parameters, general, okay, Pete, I did that, and new trajectory, let's try that again, and I just did this 2 seconds ago. There it is, double click. Forgot. Okay, so let's change that again to I-4 north, and we'll call it 1. Oh, we can drive 50 miles. If I've got a fast scanner, so I can go 55 miles an hour. We'll do 1 pass. Attributes, these are little, you can customize these. Obviously, great, intermediate, poor aren't really, that's explicit, but please customize these any way you'd like, add them, that can all be done. And call us for, well, I'm not going to go into that now, but call us for any support you need there, and you can see how those can be modified. I save it. That's my first trajectory. Again, so now I'm at 55, and my drive cost is 0 because I haven't started yet. My drive time is 0. Attributes, great. I want good GPS. You can change that to be more explicit for what you need. Now, all I have to do is insert my trajectory node. Make sure you get on the right side of the road, or the right side of the, if you go from left side and go the wrong way down the street, it won't work so well. We'll show you that in a second. And let's say I just want to go up I-4 to here. Won't be a long project, but this is where I want to end after this. So now we have a straight line trajectory, and it's 2.11 miles. But now I choose the convert trajectory to nodes to a route, and I click on that, and it took the wrong route. No problem. We reject that. Let's insert a trajectory node right here, and let's delete that trajectory node. Let's insert that trajectory node where it should be. here. And let's do that route again. Obviously, I went on the wrong side of the road here. Okay, no problem. Reject and insert a trajectory node again. And we'll just, because I probably clicked too far here, and we'll do that again. And I'm on the wrong side of the road everywhere. Okay, reject that. Let's change this node. No, everything. I did this 2 seconds ago. So let's delete the last node. That's probably my problem. And I'm on the. I left I4 as my problem. Okay, so let's delete these nodes. And let's insert the trajectory node. And I'm sorry, I wasn't paying attention. This is I4 coming up here. All right. We have a trajectory node here. Definitely I4. And here. And I'm just going to delete this trajectory. So let's remove that. And please bear with me when I do this again, which worked so well the first time I did it. So a new trajectory, we'll call it 3. We won't bother with that. And trajectory 3. And let's see why I'm having a bit of a problem. Okay, just make sure I get on the right road. And that's still I4. And as I plan that route, that's correct. Okay, so I accept that. And that's the route I was talking about. Okay, so there's a trajectory 1. Sorry, I had a little bit of a problem with that. Let's find a new trajectory called trajectory 4. Come back. Again, the node will start at about the same place. Come down to an end at the same area. And again, worked well, except. Okay. Now, so you can see how these trajectories give you very accurate. This is 2.32 miles, and based on our cost per mile, this is how much it'll cost. We're at 45 miles an hour, so it'll take you this long to drive, 3 minutes, doesn't matter. And again, very useful if you have to do some complex trajectories also. So let me try this again, and I'll come in here and say, look, if we start here, a new trajectory, my apologies, trajectory 5. We start here. We're going to go to this intersection, and then we're going to move here. And I don't want to be confused again, so we'll make sure that there's no other way of getting there. And so let's say one of the paths called for this. And then basically, again, just click on the route. Perfect route. I accept that. And then that route will be exactly 2 miles. And it'll cost another $6,000, and my total costs are being tallied here for all the trajectories. Okay, so you can see how you can lay out routes, and everyone can decide, can understand exactly where the what the distances are and what you're paying for. I've talked to a lot of service providers who, customers will say, well, you're doing this anyway, can you do this and this and this cloverleaf for me? And then in the end, you've got quite a few miles, which all transmits to cost with regard to additional miles and the like. And this basically makes it very clear what's going to be scanned, where you're going to scan, where you're going to start and stop. Okay. So I see we have a question again from Nick, or that sign still might be up. I'm going to continue. Nick, take your question sign down if you don't have a question, and I'm going to continue with control. now that we basically have our trajectories, it's control. Starting index, fine. Now this is 1,000 feet between control points. Now, typically I'm going to go one side. I'm not going to lay out all the control in this, but I want them on hard surfaces, both sides of the road, and since this is a 1,000-foot radius, I know that I'm 1,000 feet here. So let's put a control point here, control point here. I would actually be putting them here also. And once again, just as before, they're on the shoulder. Your surveyors are on a hard surface, so you can compare the trajectories effectively. Around a bridge, this is an overpass, so I really don't need to worry too much about putting them close to the bridge or close to the bridge entrance. But since I'm here, for example, I'll put control points in front of the bridge, and in front of the bridge, and behind, because underneath here, on trajectory 5, I know I'm going to lose GPS. And then while I'm here, I'll just start. And again, 1,000 feet will be here, so I could pretty much do well to put a control point here again, and somewhere on a hard surface where I can use that effectively to determine my elevations, and then I would move up here. Again, here once I'm at 1,000 feet, or whatever you decide, this is between you and the data provider. He can tell you how much he thinks he needs. You tell me how much you want. If you're just using this data, if you're consuming or buying this data, you can have an excellent conversation about where this control is, why it costs so much, why you need it, where it's placed, and why. Okay, so I would just continue this, and I'm not going to finish it here. Everyone understands, I think, what we're doing, and we could continue on like that. And again, for the control I put out, that's another $2,300. There's 32 control points so far. To finish would probably double that a little over. And of course, my drive time is $22,000, and there's a lot of information there. You can save the project, you can save the control, you can export the control, you can import existing control from somewhere. This all makes it very easy and efficient to lay out your projects. So I still see some questions. That's about it for TopoMISSION. Really, it's not much more complex than that. You saw all the. Sometimes it gets a little. If you don't click on the right road, you see what happens, but it's not difficult to fix. So we have some questions out there. So let's go back to Nick. Nick. Hello, Nick. Good questions yet?
No, there was a question from the last session.
Oh, okay. It didn't go down. Okay, that's great.
Okay.
Okay. So anybody else? Stacy, your question hand's still up, but probably the last time.
Those are not from questions. That's from something else.
That's something else. Okay. I don't understand this stuff. All right, fine. Okay. Great, guys. That's it for today. That's all we have. Once again, thank you for attending. Thank you for attending. Appreciate your support, and I want to wish you all a very Merry Christmas. And when we see you again next year, we'll be looking forward to helping you with any problems you have, with any challenges, and with becoming, increasing your success and supporting your success in LiDAR technology, and we're looking forward to a prosperous 2013 for all of us. So thank you again. If you have any other questions, feel free to email us and ask questions about what we've done today, or any one of our about TopoDOT or any other of our products. We'd be happy to help you. Again, thank you very much, and have a great weekend, and have a very, very Merry Christmas to you and your families.